Alrighty,
All right,
welcome back.
we are
Parent
ready
function
for
number 6.
Parent function number 6, exponentials. You've seen exponential before. The book uses only a base e, but we want you to know f of x equals b to the x.
Any base.
Any base. So b is greater than 1 is going to be exponential growth. So let's focus on that first. We need some anchor points, and we'll need one asymptote on this one. So our anchor points are going to be 0, 1, and they are going to be 1, comma b.
So
b being whatever that base is. So if it's 3 to the x power, it'd be 1, comma 3. Okay? The horizontal asymptote is going to be y equals 0.
okay.
All right. So again, you've done exponential growth and decay, but instead of thinking of every single base as being its own parent function, you want to just know that that ordered pair 1, comma b will be on your graph. Again, make sure you put your horizontal asymptote as a dashed line on your graph. We want to see it. We need to see those 3 key things.
All right, let's just go with this for now.
Okay, domain.
Domain is all real numbers.
Domain is all real numbers, which you can write as all real numbers, or you can write from negative infinity to infinity for interval notation. Range,
just positive numbers.
just positive, so 0 to infinity, not including the 0.
Because it never hits it.
Let's look at its symmetry. There actually is no symmetry.
Well, how about for boundedness?
It's going to be bounded below.
All right.
Asymptotes, it will only have that horizontal asymptote at y equals 0.
See if I can write it correct this time.
Very nice. There are no discontinuities.
Are you sure?
I'm sure.
Okay.
It is increasing on its entire domain, so from negative infinity to infinity. There are no extrema. No points higher or lower because it continues to go up. Let's talk about end behavior. The limit as x goes to negative infinity as we go to the left of b to the x is going to go to 0. And the limit as x goes to negative infinity, positive infinity, sorry, go to the other way, of b to the x again is going to go to infinity. So on the left side it goes to the asymptote, and on the right side it goes to infinity. Now, what if this base did not happen to be more than 0? What if it was between 0 and 1? Notice the base should always be positive. Well, that's going to give us exponential decay. What would that look like, Mr. Leckie?
Well, it's going to look exactly the same basic idea. The same anchor points, by the way, are going to exist. But this time the b value is actually between 0 and 1. So you'll get a point down here that's between 0 and 1. And you'll end up with a decayed exponential decay function that goes this way.
So curve going down. This is going to change our increasing and decreasing and our end behavior.
Decreasing on the entire domain.
Okay.
And the end behaviors are just going to be switched. So this will be infinity, and that will be 0.
Lovely.
Okay, but we're going to focus on one at a time, but the basic concept is the anchor points are the same for either function. It depends on where what value b has.
And remember, the anchor points would be the same if b was the natural number e as well.
Correct.
E
You
is just 2.7. Yeah, 1, comma e. All right, exponential functions.
That'll do it.